Welcome to notes 7.1 and 7.2. These notes are all about the Pythagorean theorem and its converse, which you should already be familiar with. So hopefully this will go pretty quickly and easily. All right, so the first thing we're going to talk about is a Pythagorean triple. And a Pythagorean triple, let me see, consists of three positive integers, which we're going to call a, b, and c. So let me see, three positive integers, a, b, and c, such that a squared plus b squared equals c squared. So it's a pattern that you will see repeated in right triangles, a pattern of numbers, and the numbers are all positive integers. Okay, let's talk really fast about the Pythagorean theorem. You should already know the Pythagorean theorem, and the Pythagorean theorem simply states in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In other words, c squared equals a squared plus b squared, and c has to be the hypotenuse, which is the longest side, the side opposite the right angle. So let's go ahead and use the Pythagorean theorem to solve for the length of the hypotenuse in each of these triangles. So we would say that the hypotenuse x squared equals 7 squared plus 24 squared. And I'm going to let you go ahead and solve this. So go ahead and hit pause and come back when you have an answer. All right, so in this case, you should have gotten x equals 25 by adding these two together and then taking the square root of both sides, which means that we have a 7, 24, 25 triple, because these are three positive integers such that a squared plus b squared equals c squared. All right, so in this case, we get x squared, equals 9 squared plus 12 squared. And go ahead and solve this one. Okay, so you should have gotten x equals 15. And then in this one, oops, we should have an x there. So x squared equals 24 squared plus 25 squared. I'm sorry, that's a 45. Having issues today. All right, 24 squared plus 45 squared. Please solve for x. Hit pause and come back when you have an answer. And in this case, you should have gotten x equals 51. So here is a list of common Pythagorean triples. You remember we had 7, 24, 25 was one of the triangles that we did on the previous page. And then, let me see, we had this one, 9, 12, 15, which is simply 3, 4, 5, which is the most common Pythagorean triple. It's a multiple of that, right? It's 3 times 3, 4 times 3, and 5 times 3. And then the other one we had was 24, 45, 51. So the nice thing is, when you memorize these triples, then you don't actually have to do the Pythagorean theorem, because you just know what the pattern is. So you can always find the missing side without having to do the Pythagorean theorem. So that's helpful when we have to do a problem like this. We need to find the area of the triangle. Well, area of a triangle is base times height divided by 2, which means we need to know the height of this triangle. Well, this is an isosceles triangle. This is an altitude, which means that it's cut this base into two congruent parts. So we have a 14 right here. So I have a right triangle with a side of 14, and I have hypotenuse of 50. And if I look up here, well, a side of 14, a hypotenuse of 50, that means the missing side is 48. So I could have used the Pythagorean theorem to find that, or I could have just recognized that this was a 7, 24, 25 triple multiplied by 2. So now we can solve our problem. My area equals my base, 28, times my height, 48, divided by 2. And when you actually do the math, you get 672, and the units are feet squared. Okay, let's do some word problems. I've got a 5-foot board, and it rests under a doorknob, and the base of the board is 3.5 feet away from the bottom of the door. So this is going to give me a right triangle. Here's my door. Here's my 3.5 feet away. Here's the board. Okay, And let's label everything. So this is a right triangle, and the base of the board is 3.5 feet away. The board is 5 feet, and we need to know how high above the ground is the doorknob. So that is the side we are looking for, which means to use our Pythagorean theorem, we get 5 squared equals x squared plus 3.5 squared. Now it asks for the answer in exact and approximate form. And remember, exact form means simplest radical. So simprad. And approximate means we're going to round. So I would like you to go ahead and solve this, giving me both the exact and the approximate form. So do that and come back when you have an answer. Hit pause now. Okay, well, you should have gotten that x squared equals 12.75, which means that x is going to be approximately 3.6 feet. Right, that's my approximate answer, and that's kind of the easier one to find, because when I take the square root of this one, okay, this doesn't work terribly well to put it into simplest radical form. But what we might want to do is sometimes it's easier to put it in simplest radical form if it's a fraction. So we could say that x squared equals, this is what, 12 3/4, which means that if I want to convert this to an improper fraction, I take 4 times 12, I get 48, plus 3 is 51. So I get x squared equals 51 over 4. Now when I take the square root of both sides, I get x equals, well, the square root of 51 is the square root of 51. The square root of 4 is 2. And my units are feet. So that would be the exact form. Improper fraction, simplest radical. I realize it's not pretty. This one's a little more useful, but that is nonetheless the exact form. Okay, so let's look at this second one. It says find the area of an isosceles triangle with a side length of 16, 17, and 17. So we have an isosceles triangle going on. Let's go ahead and draw one of those. And we've got side lengths of 16, so this is the non-congruent side, 17 and 17. And it wants us to find the area. So again, area, base times height divided by 2, which means that what we really need to know is what the height is. Okay, so if we do this, because this is an isosceles triangle, it divides this into 2 congruent pieces, which means this is 8. Now, if you've got your Pythagorean triples memorized, you right now know what the height of this triangle is. And what is it? It is 15. Okay, otherwise, you would have to do the Pythagorean theorem to figure out what the missing side of your right triangle is, which you can do, but Pythagorean triples make your life so much easier. So that means the area of my triangle is my base 16 times my height 15 divided by 2. So go ahead and calculate that for me, please. And that gets us 120, and the units are meters squared for our answer. All right, let's talk about the converse of the Pythagorean theorem. So the Pythagorean theorem basically states if a triangle is a right triangle, then c squared equals a squared plus b squared. Well, the converse of anything flips the if and the then, which means that the converse of the Pythagorean theorem states if the square of the length of the longest side of a triangle is equal to the sum of the square of the lengths of the other two sides, then the triangle is a right triangle. So we can check whether or not a triangle is a right triangle by putting it into c squared equals a squared plus b squared. And if that is a true statement, then it's a right triangle. And if it's a false statement, then it's not a right triangle. So I need you to verify for me right now whether or not these two triangles down here are right triangles. And go ahead and do that, and then come back with your answer. Hit pause now. Okay, so you should have gotten that this one was a right triangle, and this one was not a right triangle. Let's run through it really fast and see what we do. So we take the longest side, which is going to be the 3 radical 13 side, and we square it, and we set it equal to the sum of the other two sides squared. Some of you might get a little confused how you do this. Well, you're basically going to distribute the square. So 3 squared times a square root of 13 squared. 3 squared is 9. The square root squared, these two are opposite operations, so they undo each other. So we basically get 9 times 13. And it's going to equal, let me see, 6 squared is 36, and 9 squared is 81. And sure enough, if you multiply these together, you get 117, which is what 36 plus 81 equals. So 117 equals 117, and that's why this is a right triangle. In this case, my longest side squared, and we want to know, does it equal the sum of the squares of my two shorter sides? Well, in this case, when we do the math, we get 841 and we get 832. And we know that 841 does not equal 832, therefore this is not right. And that's how you use the converse of the Pythagorean theorem. The really cool thing about the converse of the Pythagorean theorem, though, is not only can it tell us whether or not a triangle is a right triangle, but if it's not a right triangle, it can tell us what kind of triangle it is. And if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So if c squared is less than a squared plus b squared, and that doesn't mean less than or equal to, I should circle it, less than, then ABC is acute, which means that if it's greater than, then we're probably talking obtuse. No, we're definitely talking obtuse, but that would be the likely conclusion. Right, so if c squared is greater than a squared plus b squared, then the triangle is going to be an obtuse triangle. So the converse is pretty handy. In the notes check today, I would like you to tell me whether these triangles are acute, right, or obtuse. I need you to keep in mind that you need to check, first of all, whether or not a triangle can even be formed. And if it can't be formed, you need to check, or you need to select no triangle. And what would cause this not to be able to be a triangle? It's my triangle inequality theorem, which states that the sum of the shorter two sides must be greater than the length of the third side in order for it to be a triangle. So the way you're going to go about doing this, I'll do one for you. Now, you probably will recognize that 5, 12, 13 is a Pythagorean triple, right? But I want you to set it up. The long side squared, and then take the other two sides and square them and add them together, and then check and see. This is 169, and this is 25, and 144. And sure enough, 25 plus 144 equals 169, and since that's the case, this must be a right triangle. All right, I want you to do the same thing for all the rest of these, and in the notes, come back and tell me, I'm sorry, in the notes check, come back and tell me what the results are. So I will see you in class. Please go on and do the notes check. Thanks.